Okay, we're going to go full screen.
Guys, we have to focus on the cons.
Okay. Yes. Over there, but he's got to move over one. All right, this is M7. No, you're going to scoot over one. All right, this is M7. Hey, this is recording. I'm ready to go. You need to get down to business. M7, lesson 9-2. Today we're going to talk about this idea of number sequences. That's what we're going to be talking about. So, number sequences. Now, the thing about a sequence, which is really not all that hard, is that this literally means numbers, and this means in order. Okay? However, do all numbers have the same order? Give me an example of a number sequence that is not 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. Okay. That is a number. I'm talking about multiple of them. You would have learned this. You would have learned how to count. Would have been an example of this. Gabby.
2, 4, 6, 8.
2, 4, 6, 8, 10, 12. Okay. What other kinds of number sequences do we have? Caitlin. 3, 6, 9, 12, 15. What other kinds of ones do we have? Yeah. 5, 10, 15. Yeah, counting by fives. All right, now I want you to go outside the box a little bit. What's another one? Yeah. Isabella?
Wait, like, what do you mean by out of the box?
I want you to think of, like
15, 30, 45, 60.
okay, that would be one. Sure, but I'm thinking even like,
Square triangle.
1, 3, 5. What am I doing here?
I know.
Parker?
Prime numbers.
7, 9.
I know when you go up one time.
Shh. All right, so this is an interesting one, right? These go up by 2, but these also go up by 2. So what's the difference?
One's odd, one's even.
One's odd and one's even. Now, someone did come up with this idea of prime numbers. That's also it. This can't be prime because 9 is not prime.
Neither 7.
Okay, 7 is. Okay, so
I have a good one.
we have sequences, orders of numbers. But sequences can be considerably more complicated than this. Okay, let me give you an example of what I mean. So let's say that I have 3, 5, 2, 4, 1. Okay, now, while this doesn't seem to have any sort of order whatsoever, you have to look for a pattern. So the question is, what am I doing between these two numbers?
You're changing them.
I am. Very, very good observation. Gabby. I'm adding 2 here. Okay, then what am I doing? Okay, then I'm taking away 3. So I'm minusing 3. Oh, that's not what I wanted, but oh well.
You wanted red.
I did want red, thank you. You know what? Hang on, let's see if I can add another pen to this. I can. And I'm going to, that's going to be perfect. And I want this pen to be red. Okay.
What about yellow?
So minus
Yellow stuff.
3. Okay, what about here now? Yeah, add 2. What about the next one?
You subtract 3.
I get it.
It's a pattern. I'm adding 2 and subtracting 3, adding 2 and subtracting 3. Okay,
I have a good pattern.
that's a pattern.
I get
Now, do you
it.
wanna see my
Parker's
pattern?
life is a good pattern. Because he's cool.
Okay,
Okay, do you wanna see my
how about, here's one. 27, 9, 3, and 1. 27, 9, 3, and 1. Anna.
Dividing every number by 3.
Okay, so if that's a hypothesis. Let's see if she's right. So we're going to go ahead and we're going to divide this by 3. 27 divided by 3 is?
9.
90.
Okay. 9 divided by 3.
3. Then
8.
1.
3 divided by 3.
1.
1.
If it kept going, what would be the next one?
0. Minus 3.
Negative.
1 divided by 3 is?
Negative.
3.
0.
Parker, 3. It'd be 3.
1 over 3 is 1
It's as long as it can.
1/3.
Is it?
It's a fraction. We can go into fractions.
No.
No.
27 divided by 3 is 9. 9 divided by 3 is 3. 3 divided by 3 is 1. 1 divided by 3 is 1/3. So the next number in line. Hang on. Hang on. Command Z. The next number in line would be 1/3.
We're gonna keep going on with 1/3.
Okay, let's look at some more examples. This takes a lot of practice, getting in the habit of seeing these. Okay? All right, here's one from the book that I think would be pretty valid. Okay, let's look at this. They make a table. Oftentimes, these are represented in tables. And in this table, I'll just put the numbers. You need 5 boxes, like so. And we have 1, 2, 3, 4, 5. And we have 44, 35, 26, 17, and 8. Okay, now the 1, 2, 3, 4, and 5 on top are just telling us what's happening as it goes on. So really, we're going to look at the red numbers. We want to look at the red numbers. All right, the very first thing I'm going to do is I'm going to notice what's happening with the red numbers. All right, so this is, I mean, I'm not asking you to solve it. I'm just saying, what are they doing? What are they doing? Anna Harvey. They're going downtown. They're going down. Okay, so they're going down. Okay, hands down, hands down. Here's, when you know they're going down, there's two ways numbers can go down, or a couple different ways numbers can go down, right? We can do what to get a number to go down? Yes.
You could subtract them by 1.
Okay, okay, but let's not go specific. We could subtract. Okay, take away some numbers. We could do what, Savannah?
Multiply by 0.5.
Okay, we could multiply by a decimal. Absolutely. We can do what? Yeah? We can divide. We can also add negatives.
What?
Right? I add -5. It's like subtracting 5. So we can do all of
See what you
it.
did there.
Let's look at how much it's going down each time. So to 44 to 35 goes down by how much? Goes down by 9. So here I would say we went -9. All right. 35 to 26. What did we go down by? Did we go down by 9?
Yeah, you went down by 9.
Yes. I'm sorry.
Okay, so going in this direction, we're saying we're subtracting 9 and subtracting 9. What if I had asked you to describe it going in this direction? What would you have done? Yeah. Isabella?
Oh, you would have
Yeah, it would have been like adding 9 going in the other direction.
And 9.
So we call this a change. It's changing by how much? Because it can go up or it can go down depending on how you're looking at it. It's changing by how much? Each time, yeah. 9 each time. It's changing by 9. Now, in this problem, however, they don't leave it there. They ask you to find the next 3 values. Okay, so that's not really that hard now that you know the pattern. All right, so we're going to find 6, 7, and 8. So, someone help me out here. Hannah Harvey, what's going to be the next one? -1. Very good. And the next one?
I know the next one.
Savannah?
-10.
-10. And finally, Caitlin, what do you think? -19. So, not only did we find the pattern, but then we were able to predict. And that's the power of number sequences, right? Being the power to predict.
The power.
Okay,
Sure.
I'm going to give you a real-life example that I have to live with because my brother was born on leap year. All right?
That's like
It means my brother only has a real birthday every 4 years.
Wait, how? How old is he?
The day that he was born on doesn't occur in the calendar, but every 4 years. He's born on the 29th of February. There's only a 29th of February every 4 years. Okay? So, my brother was born in 1996. Okay? My brother was born in 1996.
Wait, so wouldn't it be if there was no... When did carry birthday first?
So, in what year? All right, now this is a sequence, right? Because we have to jump by what for leap years?
4 years.
Every 4 years. So, when was his first real birthday?
2000.
2000.
That's awesome.
That's when he turned 1. Okay? When was his second birthday? Hannah Harvey? 2004. That's when my brother turned 2. Hannah Harvey, when's the next one?
I'm 2 years old.
2008.
Wait, so he
That's when my brother turned 3. Here's what I want you to do. With the person next to you, find out when my brother turns 10.
A year.
Yeah.
My grandma, she was born on a leap year, and technically she would have died at the age of 12.
Mr. B. Mr. B, but when they count it as... Mr. B, but when
Yes?
they count it as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so they actually count it as 7. Come on.
He
You got it. So your brother's 4 years old right now?
Shh. All right. What do you think the answer is, Gabby?
In 2039.
2039. All right, let's see if we can get there. All right, so in 2012, he would have turned 4. In 2016, he's going to turn 5. So next year, my brother will be 5. My brother will be starting college as a 5-year-old, probably the youngest college student ever in his life. At 2020, my brother will return a remarkable age of 6. Okay, we're starting to get really into kindergarten.
That's when flying
So
cars are gonna be.
he should have been probably starting kindergarten, 1st grade, but he's accelerated.
But your son or daughter, when they're born, they could potentially be older than you.
Yeah. 7 years old.
We're older
I
than
know, I'm less mature than him, and I'm still older than him too. I'm a daughter.
8. 2032 would have been 9.
I'm still older.
2036 would have been 10 years old.
Wow.
All right.
No, but they really, but he's still going to college.
No, he's not.
No, how? He can still have his driver's license, though? Does he still get his driver's license? Really? No.
It's very interesting, but when it comes to leap years, they move your birthday date to the date of your choice. So it can either be March 1st or February 28th.
March 1st.
So his birthday changes. But nonetheless, because it's literally a birth date, well, the date of his birth, the 29th of February, doesn't happen every year. So here's what we're talking about here, right? There's 2 number sequences here. All right, there's what about the years? What is that sequence? Okay? Yes. It's going up by how much every year? Every time? 2000, 2004, 2008, 4 years. But his age is going up how much? 1. These are an example of two number sequences. Ordered arrangements of numbers. Ordered arrangements of numbers. Okay, we're going to take this just a little bit further. And we are going to go to the next page. Let's look at this. Okay, this is the first pattern. And this is the second. Hang on.
And then a triangle.
That's the second drawing. This is the third one.
Oh, you don't have your autocorrect on here anyways.
Oh, man.
Yeah.
Look how bad that is now.
That's not nice.
Okay, draw the next image in this sequence.
I can do
Did
that.
I just do this in ISEP a while ago?
So this is the first
We're not
number,
supposed to talk about
second,
stuff.
third. What would the fourth image in the sequence look
Can
like?
I draw it? Can I have one more block on each end?
Okay,
Are you sure, Jacob?
so it'd be one in the center. How many on the top?
3.
That's what all the evidence today.
And then another 3. And then another 3. Let's get across. Another 3. And then a 3.
You're right.
Nice job.
It's a tone, thank you.
All right, so that's an example of a sequence. Let's look at,
Hi, Mr. B.
all right, last but not least. 2,
Wait, yeah.
4,
It is least.
8, 16, 32, 64, 128.
I know.
Yes?
You multiply 2 every time.
All right, so in this particular sequence, it's not addition or subtraction. It's what?
Multiplication.
Multiplication.
Nice job.
Multiplied by 2, by 2, by 2,
So smart.
by 2.
I know I am. Let's look at this picture.
All right, let's go a little bit, let's go one more.
Probably.
8.
I have one. 3 triangles.
Add another 3 to the other side. You forgot to add the other side. You know, just here.
Put it on record. I'm just covered. I'm sorry. I put it far away.
All right, this one's going to be really important. Okay, here we have a sequence, except now I'm going to tell you that it has something to do with 3s, but I want you to figure out what goes here each time. 3 to what power gives you 3? Mr. Miller?
3 squared.
All right, 3 squared is what? 3 times 3 is? 9. So that's what we would put here. 3 squared is 9. Okay? So what do you think goes here? And the very first one. Feel free to use page 445 as a help guide, especially at the very top, which is part of your homework this evening. Savannah.
0.
Okay, if I go 3 to the 0 power, I'll give you a hint. Anything to the 0 power is 1. So we're going to go up just a little bit. So it's between 0 and 2. Savannah, take another shot at it. 1. So already a pattern is starting to establish itself. Now we have to figure out what that looks like. So 3 to the first power is 3. 3 squared is 9. 3 to what power gives me 27? Yes. 3 cubed. Excellent work. Yeah, absolutely. So now what that means is we're taking 3 times 3 times 3. 3 times 3 is 9. Times 3 is 27. And then that leaves us at this idea that since we already established a pattern, it's pretty easy. This last one here is probably going to be what, Millie? 4. That's 3. Times 3 is 9, times 3 is 27, times 3 is 81. So there's 3 itself. 3 times 3, 3 times 3 times 3, 3 times 3 times 3 times 3. Okay, that's what this looks like. It's pretty useful to us. Now, we could take this a step further and we could say, okay, 3 to the 5th. Okay, what could that possibly equal? How would you do that on a calculator? Because I'm not going to ask you to do a problem like that in your head. That's a lot of mental math. What would you do, Savannah?
You do 3 times 3 times 3 times 3 times 3.
Excellent. Yep, 3 times 3 times 3 times 3 times 3, which is 123, I think, right? Yeah. Oh, no. No, don't tell me. 80 times 3 is 240, plus 3 is 243.
Yeah.
Yes. So, 243, and then beyond that, my skills are, wow, that is definitely not math. No, wow. Okay, just gonna get rid of that. 243. Okay, there we go. But that's not it. And you'll see in the book, they give you some examples here of kind of what that looks like, okay, as far as on 23, 24, and 25. You'll see this come into play. And part of it is they're asking you, what could this bottom number possibly be for each of those sequences? All right, at this point, I'm ready to give you your assignment. All right, it is a kind of a hodgepodge of items, so I'll write it up here on the board so you can reference it.
That's just what I was gonna
Which one?
The arithmetic, geometry.
Okay, that's a good thing to learn about.
Did you forget about it?
Yeah, thank you for bringing it to my attention. That is
You're welcome.
what you call a good use of your text. There are definitely different types of sequences. So, sequences. Okay, here's what this looks like. You have arithmetic sequences. And that's a really good word to spell. Arithmetic sequences. Arithmetic sequences mean that you are adding, subtracting, multiplying, or dividing. Okay? Or, excuse me, you are adding or subtracting. Then, geometric, however, means that you are multiplying or dividing. Geometric, so multiplying or dividing. Now, the gray area for students often falls into that whole power business. So 3 squared. Okay, would that be geometric or arithmetic? It's geometric. Really, what are you doing here? You're multiplying or dividing?
You're basically taking 3 times 3.
Yeah.
Would be geometric.
Right, be geometric because you actually end up multiplying. So if you were asked to find something like identify whether it's a geometric or arithmetic sequence, let's go back and identify all of our different sequences here. Okay, would this be geometric or arithmetic here?
Geometric.
My
Arithmetic. I said the wrong thing. I'm sorry.
arithmetic. Down here, I'm dividing, so what would that be?
Geometric.
Geometric. Here, I was adding and subtracting, so that would be, Caitlin? Arithmetic. Here we were adding both situations from year to year, so that's arithmetic. Okay, here,
Adding. Yeah, you're adding blocks on.
you're adding blocks on.
Multiplying.
No, you're just adding.
You could say both or neither. I would say neither here, because you're not really adding or subtracting, you're changing the shape. Okay? Here, multiplying or dividing.
Multiplying.
Geometric.
You're multiplying, so it's geometric. Here,
Geometric.
geometric. Okay, and then we're back to the beginning. And I wanted to go back. Come on. Okay, really?
Don't break it.
I won't. Here. All right, 2, 4, 6, 8, 10, 12. This is obviously what?
Geometric.
Okay.
Multiplying by 2.
Am I multiplying by 2? 2 times 2 is 4. 4 times 2 is 8.
No, I meant adding 2.
Adding
Oh,
2.
that's arithmetic.
Whoa.
Right. All right, 3, 6, 9, 12, 15. Yes?
That's arithmetic.
Arithmetic.
Adding.
Adding 3 each time. 5, 10, 15, 20. Yes. Arithmetic. Okay. Yes? Arithmetic for the bottom one. Now, 5, 10, 15, 20, that's an interesting one. I'm going to take a look at that one real quick, and then we are going to be done.
That could be both.
Arithmetic. 5, 10, 15, 20. Let's say that I'm doing this, let's call this part 1, 2, 3, and 4. All right, I'm adding 5 each time. Would you agree that 5, 10, 15, 20, I'm adding 5 each time? Yeah. But could you also say that I'm taking the place it is in the sequence and multiplying that by 5 as well? 1 times 5, 5. 2 times 5, 10. 3 times 5, 15. 4 times 5, 20.
Like both.
So this one can actually be construed, which means looked at both ways.
Tricky.
All right, now into your homework since we're pretty much at the end of our time. Your homework, ladies and gentlemen, is going to be page 444. This is patterns. That's basically all this homework is. 1 through 5 all. That's not it. That would be pretty sweet if that was. 6 through 18 evens. That's not all. It'd be pretty sweet if it was. And 22 to 27 all. This actually won't take you all that long to accomplish, since a lot of the examples we did in class today. All right, have a good afternoon. If you have any questions, email me. Today is Tuesday, so no. You are headed back downstairs.
Wait,